This is number 49. On page 398. And it tells us what is the free fall acceleration. So we're looking for G in a location where the period of a 0.850 meter long pendulum is 1.86. So we're given T is 1.86 seconds, and we're given the length of the pendulum is 0.850 meters. So what do we do? Well, we have to know our equations, which one of them is, and the only one for a pendulum is 2 pi, T equals 2 pi, square root of L over G. So we are actually looking for G. Well, again, this is just a simple plug in your numbers. And G's are unknown here. So what do I do? Well, I've got to square everything to get rid of this radical. But before I do that, I could divide both sides by 2 pi, correct? And if I do that, I get 1.86 divided by 2 pi. And that gives me, you got to put parentheses around your 2 pi to get the right answer. It gives me 2.960. So 2.96 equals the square root of 0.850 meters over G. Whoops, I just did the wrong thing. Hold on, 1.86 divided by parentheses 2, second pi in parentheses. Sorry, this is, I put in the wrong number. It's actually 0.296. There we go. Now I'm going to square everything, square both sides. When I do that, I'm going to get on the left-hand side 0.0876, and that'd be seconds squared equals, the radical's gone now, 8.50 meters over G. Well, to solve this problem, let me fix this over here. This is bugging me. 0. I'm going to basically, when I do the algebra, I'll end up switching those two. So I will get G equal to 0.850 meters divided by 0.0876 seconds squared. And that's going to give me 9.7 basically. Let me see what they got in the answer. I get 9.69957, and the answer they got is 9.70. That's what I thought. So they round off to 9.70 meters per second squared. And there again, if you just know your equations, that helps. You know, like for the first chapter, just going by memory here, we know that frequency equals 1 over T, and T equals 1 over frequency. We know that the period of a pendulum is 2 pi square root of the length of the pendulum over the acceleration due to gravity. We know that the period of a spring, this would be a spring instead of a pendulum, is 2, looks the same, 2 pi square root of the mass in kilograms over the spring constant K, that's in newtons per meter. And what else do we know? We know F equals negative K delta X, where delta X is how far the spring stretches. K is the spring constant in newtons per meter, and F is the force that we stretch the spring with. And I think this was also in chapter 11. V equals velocity in meters per second equals lambda, which is wavelength in meters, times frequency, which would be hertz. That's cycles per second, where period up here is seconds per cycle. All right, and then chapter 12, what did we have? We had intensity, how loud a sound is equal to power in watts over 4 pi r squared. R is the only thing squared there, and r is the distance away from the sound source in meters. Power's in watts, intensity in watts per meter squared. We know that a beat frequency is equal to the absolute value of frequency 1 minus frequency 2, just make it positive. And then last but not least, we know that for an open pipe and strings, that the frequency of resonance is equal to N, that's the number of antinodes, times velocity of sound in air or velocity on a string, divided by 2 times the length. Or for a closed pipe, the frequency of resonance would equal N, that's the number of antinodes, but here, over here it can be 1, 2, 3, dot, dot, dot to infinity. Here it can only be 1, 3, 5, it can't be even. V, that's the speed of sound in air, over 4L. And I will give you this number here to use on the test. All right, so you don't have to memorize any of that. That's all the equations, as long as you know, you got to know what all the letters mean and what they go with, and then it's just like this. I just plugged in numbers in, solved. Nothing real tricky as long as you know your equation. So work on those equations, write them out, put them on note cards, say them to your friends, redo some of your homework problems, and you should make a good grade on this test as long as you know these equations and you know how to use them. There's nothing really tricky about any of those. Nothing elaborate like the last test.